So this video we're going to talk through the quotient rule, and this is kind of the question we're going to look at first, but we're not going to use the quotient rule. So currently for this question we could use product rule, because we can rearrange this so we get y equals brackets 3x plus 1 brackets x plus 5 to the power of negative 1. Because it's on the denominator, we've got a power of negative 1. Okay, and then we could use product rule, so u would be 3x plus 1, v would be x plus 5 to the power of negative 1, and du dx, we could then differentiate the 3x plus 1, it's gone a bit blurry, and get 3, and we could differentiate dv dx, and we would get negative brackets x plus 5 to the negative 2. Okay, and then we want to use product rule, so we would have u dv dx, so dy dx, you don't need to write this one down, so we'd have 3x plus 1 u dv dx times negative x plus 5 to the power of negative 2 plus v, which is x plus 5 to the power of negative 1 du dx, which is 3. Okay, and then if we kind of rearrange this, we get negative 3x plus 1 over x plus 5 all squared on the denominator plus 3 over x plus 5, and then we can take 1 over x plus 5 squared, kind of factorize it, so we would end up with negative 3x plus 1 plus 3 lots of x plus 5, and I might be able to fit it in. So then if we kind of sort this out a little bit, obviously we get 3x plus 15, but we've got negative 3x plus 3x, so we cancel out, and 1, this should be a negative 1. This should be in brackets, I do apologise. So negative 3x plus 3x, negative 1 plus 15, 3 times 5, so we would get 14 over x plus 5 all squared. Okay, there's a bit of a faff kind of working through it all. Okay, so we could use something called the quotient rule, and the quotient rule is where we've got y equals u over v this time. So this is the actual quotient rule. I recommend you write it down. Okay, so if y is equal to u over v, then the differential is equal to v du dx, take u dv dx, all over v squared. Okay, so we're going to use the same question again as we've just looked at, but this time we're going to use the quotient rule. Okay, so this time we have that u is equal to our numerator 3x plus 1, v is equal to our denominator is x plus 5, du dx is 3, dv dx is 1, so my differential is v du dx, take u dv dx, all over v squared, so v is x plus 5, du dx is 3, take away, u is 3x plus 1, dv dx is 1, so I don't need to write it, all over v squared, x plus 5 all squared, and then when I expand this I get 3x plus 15, take away 3x, take away 1, all over x plus 5 all squared, which is equal to 14 over x plus 5 all squared. So we get the same answer down here and up here, but this one is a bit more, it's a bit faffy. There's a lot more steps, and it's a kind of a bit of a pain with all of these indices and with more fractions, and obviously I made a mistake with the brackets as well. I made a sign error. Okay, so quotient rule can be a lot quicker. Okay, so I'm going to talk through some formal examples. So this is the first one that we're going to do. So we've got y equals x plus 1 all squared over 3x take 2. So u is going to be my numerator, which is x plus 1 all squared, and v is going to be my denominator, which is 3x take away 2. du dx, so differentiate with respect to x. It's gone a bit blurry. I'm going to use chain rule, so it's 2 bracket x plus 1, take 1 from the power is just 1. dv dx, when I differentiate this, I just get 3. My differential, so dy dx, I have v du dx, take u dv dx, all over v squared. V is 3x take 2. du dx is 2x plus 1. Take u is x plus 1 all squared. dv dx is 3 all over v squared, 3x take 2 all squared. And then I'm going to rearrange this, so equals. So I've got, when I kind of expand this, I can take x plus 1 out at the beginning, because both terms on the numerator have an x plus 1. So the x plus 1 there and one of the x plus 1 terms here. So that means I'm multiplying by 2 lots of 3x plus 2. 2 lots of 3x take 2. Take away 3 lots of x plus 1. All over my denominator, 3x take 2 all squared. Might just be able to fit this in. So when I simplify this, so I end up getting 2 lots of 3x, take away 3x. So I get x plus 1 brackets. I'm going to write it up here so it's a bit clearer. So I'm going to get x plus 1 brackets, 2 lots of 3x, take away 3x is 3x, 2 lots of negative 2, take away 3 lots of plus 1, so I get negative 7 all over v squared, which is 3x take 2 squared. It's kind of a bit blurry. Okay, so that's that question finished. Your second example is here, but we've got a square root instead this time. So my u is x, I've got hiccups, equals. So my u is x, and my v, I can write it as square root of 1 plus 2x, but I know I can also write the question as x over brackets 1 plus 2x to the power of a half. So that's what I'm going to use for my v, 1 plus 2x to the power of a half, because to the power of a half is our square root. Okay, and then I'm going to use my differential, so du dx is just 1, dv dx is a half, times the differential of this is 2, lots of 1 plus 2x, take away 1 is negative a half. So I can't leave it like that, so I'm going to simplify it. So a half times 2 is just 1, so brackets 1 plus 2x, all to the power of negative a half. I'm going to write out my formula for the quotient rule. So dy dx is equal to v du dx, take u dv dx, all over v squared. And then I'm going to start to substitute them in. So v is 1 plus 2x to the power of a half. My du dx is just 1, so I don't need to worry about that. Take away u is x, and dv dx is this, so 1 plus 2x to the negative a half, all over v squared, which is this. But if I square that, if I square a square root, you end up with just the power of 1, so the denominator is 1 plus 2x. Okay, then we're going to start to sort this out so it looks kind of a bit neater. So the first bit, there's nothing we can do currently, so we've got 1 plus 2x to the power of a half. This part would change into x over 1 plus 2x to the half, all over my 1 plus 2x. Okay, and then what I can do to my numerator, so I can sort it out because it doesn't look kind of the nicest. I'm going to multiply kind of everything by 1 plus 2x to the power of a half, so that I get rid of this denominator. So I'm going to multiply everything by 1 plus 2x to the power of a half, so that that denominator disappears and it's a little bit easier to deal with. So this, I would have 1 plus 2x to the power of a half times itself again, so times 1 plus 2x to the power of a half. If I multiply this by 1 plus 2x to the power of a half, I just get take x. And my denominator, I would get 1 plus 2x times 1 plus 2x to the power of a half. So that's got rid of that horrible denominator that was part of my numerator as well. Obviously, fraction within fraction isn't the best move. So 1 plus 2x to the power of a half times 1 plus 2x to the power of a half. Okay, that just becomes 1 plus 2x. So 1 plus 2x. I've still got the take away x, and then my denominator, this is the power of 1, and this is the power of a half, so my denominator is 1 plus 2x to the power of 3 over 2. Okay, and then I'm just going to neaten up my numerator, so 2x take away x is x. I've still got the 1 plus 1 all over 1 plus 2x to the power of 3 over 2. So it does seem quite long, okay, but it's harder to kind of differentiate using kind of other method, and also there are some questions that you can't always use another method. You have to be able to use quotient rule. Okay, it might seem the hardest out of the quotient rule and product rule, but once you get the hang of it, then you'll be doing questions kind of a lot quicker. Okay.